Today we are going to be finding the trigonometric functions for a 15, 75, 90 degree triangle. And we're going to do this by combining a 45, 45, 90 degree triangle and a 30, 60, 90 degree triangle in this fashion. And then we're going to superimpose a 45, 45, 90 degree triangle by adding the 15, 75, 90 degree angle in this fashion. We're able to do this because the 15 and 30 add up to 45. Angle A is still the same as it was before, and the angle C created up here is a 90 degree angle. So first we're going to find these various values here for AD and EB. We're going to use the Pythagorean Theorem. It's already written here, but I'm going to show you the steps. So it's going to be the sides added together squared. Each side squared added together equals the hypotenuse squared in this fashion. The A squared plus B squared equals C squared. So we have AE 1 squared plus ED 1 squared equals AD squared. So we get 2 over here equals AD squared. Take the square root of both sides, we get square root of 2 equals AD. That's what we have here. Likewise, we're going to find this for EB. So we have, so we're doing it a little differently. The hypotenuse is going to be 2 here. So we have, let's see, 2 squared equals 1 squared plus EB squared. So we get 4 and 1 plus EB. We get 3 over here. We're going to take the square root, and we get EB equals square root of 3 as listed here. Now we know that, let's see, AB, AB equals BC times square root of 2. And how do we know this? We know that the relationship between a 45 degree triangle and its sides is 1 to square root of 2. So we know that AB here is going to equal BC times the square root of 2. Now we already know what AB is. We know that it's 1 plus square root of 3. So we can plug that in here. 1 plus square root of 3 equals BC times square root of 2. We divide both sides by square root of 2. And that leaves us with BC, because the square root of 2's cancel out. Now we can't just leave it as over the square root of 2 here. We have to have a rational value in the denominator. So we're going to multiply both sides, or the top and the bottom, by square root of 2 over square root of 2, because you can multiply any number by 1, because this is any number over itself is equal to 1. So we end up with BC equals, let's see, we get square root of 2, we get 1 times square root of 2 plus square root of 2 times square root of 3 all over square root of 2 times square root of 2. Now the square root of 2 and square root of 3, the inside part of the square roots multiply together. So we get square root of 2 plus square root of 6. The square roots cancel out in this case, and we get just 2. As so. Now, we know that DC here, we're trying to find this value. We know that DC DC is equal to AC minus AD. So by plugging in what we know that AC is equal to BC. So we can plug in what we do know here. Let's see, we know. So we know AC equals BC, which is what we just found out. So we have DC equals the square root of 2 plus square root of 6 over 2 minus the square root of 2, because we know AD right here, square root of 2. Now we have to have like terms over here, so we're going to multiply this times 2 over 2. So we end up with square root of 2 plus square root of 6 minus 2 square root of 2. And that's all going to be over 2. Now these cancel out, so we're left with square root of 6 minus square root of 2 over 2. And that's going to be our DC value. So we figured out all of our values for our 15, 75, 90 degree triangle. So I'm going to redraw it right here. Let's see, we got C, D, and B. So our BC value here is square root of 2 plus square root of 6 over 2. We have square root of 6 minus square root of 2 over 2. And our BD value is just 2, because that's what we defined it as originally. So we know that B is going to be our 15 degree angle. So we're going to use a little trick here to determine the functions, the trigonometric functions for a particular value. We have the SOHCAHTOA. Whoops. SOHCAHTOA. So sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and the tangent is opposite over adjacent. So 15, the sine would be the opposite over the hypotenuse, the cosine would be the adjacent over hypotenuse, and the tangent would be the opposite over adjacent. So doing these down here, we have sine of 15 degrees is equal to the opposite over hypotenuse. So we have square root of 6 minus square root of 2 over 2. And that's going to be divided by 2. I elected not to put the 2 down here because it'd be 2 sets of division, which is just kind of messy. But we know that the 2 drops down underneath here. So we end up with square root of 6 minus square root of 2 over 4. And that is our value for sine of 15. Now if we go ahead and do cosine of 15, so we're going to have adjacent over hypotenuse, which is going to be square root of 2 plus square root of 6 over 2 all over 2, which is going to give us square root of 2 plus square root of 6 over 4. Now for the tangent, it's going to be a little different because we have the opposite over the adjacent. So we get opposite is going to be square root of 6 minus square root of 2 over 2. And I'm going to go ahead and flip and multiply because that's the division. If I drew out divided by square root of 2 plus square root of 6 over 2, that would flip and come up over here. So we get 2 over square root of 2 plus square root of 6. Now these 2's are going to cancel out. We're going to be left with square root of 6 minus square root of 2 over square root of 2 plus square root of 6. Now again, we can't leave this on the bottom, so we're going to do square root of 2 plus square root of 6, square root of 2 plus square root of 6. So we end up with, bring it down over here, we're going to FOIL this, so we end up with 2 square root of 6 times square root of 2, which is going to give us square root of 12. First outer FOIL, square root of 6 times square root of 6 is going to be square root of 36, which is equal to 6. To the inside, negative square root of 2 times square root of 2, which is going to give us negative 2. And we're going to do negative square root of 2 times the square root of 6. So we end up with negative square root of 12. These cancel out. This reduces to 4. And these multiply together the same fashion. So we have square root of 2. So we get square root of 4 outer plus square root of 12 inner. We get square root of 12. And last, we get square root of 36, which changes to 2 plus 2 square root of 12 plus 6, bringing that over to here. 6 and 2 combine to be 8 plus 2 square root of 12. Now square root of I've made a mistake here. Not quite sure how to get the square root out of the bottom here. Drawing a blank on how to do that. But your answer is still going to work out if you ignore this part. This is a correct answer. It's just not in the nicest of terms. I'm not quite sure how to pull out the square root of 2 or the square roots down here, but you get the idea of how it works for general functions.